one, I can drag them to a breakout room. Or if someone just has a question that only a subset of students want to listen to, same idea. So who
I've
has
got a
questions?
question if I can ask it. I'm having trouble with Project One. Like I can't even like compile like it won't let me do the GPD compiler.
You mean on the Bomb Lab project too?
Yeah, PopLab.
Um, you shouldn't compile bombs.c. You should already have a compiled bomb in there.
Oh, that's what bomb is.
Yeah. So I
Okay.
wouldn't run it quite yet, but if you do like dot/bomb, it'll run it. And the
Okay.
PDF shows how you would give it a text file to redirect the output.
Okay, that whole part kind of confuses me as to how to debug that. Could I get a little help with that?
Yeah, and if it would be useful to everyone, I could just share my screen in the terminal, and I'll kind of show how to use like object dump and a little bit of GDB to kind of walk through the bomb. Would that be helpful?
Yeah.
Cool. So let's do that. And also, for anyone who wants to like ask me a one-on-one question, like if it's a grading, whatever, just say so, and I can move us to a one-on-one talk. But for now, let me open up Terminal and connect to Schofield. Okay, you guys should all see this, right? And we actually go ahead and kill the volume on that too. Okay. Cool. So let me actually see if I can find a whole command. Cool. So first thing we're going to talk about is object dump. So this is kind of the syntax for it. The PDF has these commands, but let me also make sure I have my chat out. -t is going to give you this information, which is basically, let me refer to the PDF so I can get the exact terminology correct. One sec. But this is going to show you all the, it's not going to be keywords. One sec. Just want to make sure I use the right term. Symbols, that's what I need. So these are going to be symbols, which are going to be basically most of the functions themselves, and also kind of like anything else that's kind of like global. So this kind of information is still kind of retained even after compiling. So we can see a bunch of nonsense in here, but we can also see some familiar lines like input strings or blank line, phase 3, phase 1, initialize bomb, solve. Those are going to be the kind of key ones that we look for. In fact, if you do this pipeline character, that kind of stands for like a, it is a pipeline character, so it pipes into a new command. I can do grep, and if I do, grep is going to be like a string filter. And if I actually just type in phase underscore, it will get me all the phase information. So this is useful because this kind of lets us know what the function names are, and kind of where they're located. So you have to be careful when you look at this information here. This should be where it's kind of reserved on memory, but since the program's not being ran, this is kind of, think of it as like relative memory. So for example, suppose that this translated to 10. This isn't saying that it's the function phase diffuse is located at memory address 10. It is saying that once it's loaded up in memory from wherever the start of the program is, plus 10 is where it's going to be at, if that makes sense. Does anyone have any questions on that part? Cool. So once we have that information, we also want to use the other flag, which is going to be -D on bomb. And we're going to get a lot of information here. So essentially, this is going to reveal each function, for example, in a init driver, and the exact assembly code of what it's doing. So again, a lot of this is going to be nonsense, so we can filter this to find what we want. Well, I know from the previous command that phase1 is a header. So I can search for, I can do grep and search for that. And keep in mind, what you can do also as well is if you do this little right arrow, that is a redirect, and you're telling it to redirect to a text file, and that text file has all the same info. So if you prefer to open up that in like a text file and do like Control F and that kind of stuff, whatever you're most comfortable with, that's a solution. But for now, I'm going to keep on using grep. So I can actually grep for phase1 and find it in that huge dump. And grep has a useful command called -A, which is a head. And I can it'll just find out where it is in the file and then print 10 lines ahead. And actually, I'm going to get more specific with my search string here. Really? It probably wants quotes. Yep. There you go. Sorry, I'm just trying to get this formatted very nicely. There we go. So this is going to essentially show the assembly that is in phase1. And so the idea is that you have to look at this and kind of interpret it to try to figure out what it means. You would have to do, it would basically be a constant, okay, this is a $sign, so I know this is the constant. What's RSB? I have to like kind of look into that and see what register that is and what it's referring to. I can see that it's doing a subtraction command, calls, tests, and so on. So you're going to basically have to translate that from assembly to kind of like real code to figure out what would cause the bomb to not explode. Specifically, we can see that it tests some condition, and we have to try to figure out what we would need to pass in to make that condition true. What are your guys' questions on that? I'm going to leave an awkward pause here for a bit to let you guys think. Okay, cool. So that's going to be the logistics of kind of like starting out with the bomb lab. And you're kind of repeat this process for each of the phases. And as we kind of move on, they're going to get harder and harder. Yeah, this one, for example, is a very long one. Wow. Still going. There it is. It's like 35 lines. Any other questions? Just in general about the lab or not? What's the format of the test? I believe Meehan just posted a big old created an assignment for it that has a lot of description, a huge description for it. I think it's like, I think you're allocated like 2 minutes per question, and it's all on Canvas. I would refer to his post on it for more information. you repeat the previous question, other than like my answer to it? I said that Professor Meehan posted the assignment, and when you click on it, there's a big paragraph that explains the format of the test. It'll describe like what you should expect. Yeah, I haven't looked at the exam, so. Oh, it says locked? Okay. It's hard to say. It's kind of all up to discretion. Typically, in my experience, professors curve depending on how the class does. So yeah, let me click on the exam here real quick. Realistically, it should tell you the format, even though you can't take it yet. It says here that there's going to be 54 questions, ranging from 1 point to 4 points. You're expected to have a little more than 2 minutes per question, and some of them might be quick responses. Some of them might need you to work out some math on a scratch paper. And it's about as much information as I can give. And I think his Canvas announcement also mentioned that it's going to be on the first 3 chapters of the book. But make sure you cross-check that. Yeah, the test will cover the first 3 chapters of the book. So, which is it's going to be like Canvas quiz, so it's hard to say. It's kind of whatever he wants to do on Canvas quiz. So it could be like multiple choice, or it could be fill in the blank. If I remember correctly, I think it was all pretty much multiple choice. But don't take that as like a promise, because there's nothing stopping him from changing it. And I think the exam is open book, but let me verify that. I think it's probably in the syllabus that he says it. Yeah, all exams in this course would be open book. But that being said, don't rely on kind of like the open bookness that can get you through. The issue with a lot of his questions are going to be ones that, like, if you know the material, you can answer fairly quickly, but to search it up, it might take a little bit of time. I think so. If you're in doubt, I would say not to click on it. But normally in quiz, it's always going to be like, you have 2 hours to complete this lab from now. You know, when you're ready with this exam, when you're ready, go ahead and click start. Typically, I don't think clicking on it will start the exam. But if you're scared to, I would just not click on it at all until you're ready. The information available in the text box is pretty much what I described, which is 54 questions and 2 hours to complete them. And if you guys want to just talk about some of the concepts in the book, we can totally do that. Feel free to utilize this time however you want. My headphones actually died too. I'll be right back. All right, sorry, I'm back now. I would say it's safe to do so. Safe to assume that. If you can answer all the homework problems, sorry, I shouldn't even say homework. If you can answer like the problems in the back of the book, with like high confidence, I would say you would have a pretty good chance at the exam. Something I did to prepare this exam when I took for this class was I did all the problems in the back of the book or at the end of each chapter, and you don't have to like go through them and like handwrite the answer to each one and like type out the answer or whatever you want to do. If you just look at the question and then think to yourself, yes, I have a good idea of how to approach this answer, the question, and I feel confident enough in that, you can just kind of go on to the next question. If you get to a question where you're like thinking to yourself, well, gee, I'm not really sure how I would go about doing that, then that might be a good question that you can spend a little time reviewing, trying to figure out the answer. Let me look at the book so I can review the chapters. Let me just quickly find a copy of it online. To answer your question about bomb, yeah, if you're stepping line by line, then you can see when it's about to call the explosion. But ideally, you probably would set a breakpoint at the function itself, because if you do those commands that I showed, like the whole header things, the symbols, you'll be able to find the symbol for explode bomb. And so if you tell GDB, hey, if you're about to step into this function called explode bomb or whatever it's called, stop. And if you're wanting to be like extremely careful, I would like put multiple stop points, just not let it go through at all. Give me 1 sec. I'm still gonna try to find the book. Just need to get the name of it. It's like computer systems programmer's perspective. Yeah, that's what it is. All right. Give me a moment. I'm stepping through the chapters right now, and I'll kind of just point out what I think is useful. And also keep in mind that I have not seen the exam, nor did I help write it. So take everything I'm saying with a grain of salt. There might be things that I mention that aren't covered, and there might be things that I don't mention that are covered. So treat this as you will. I would say you need to understand how programs work on a machine. That is, you need to understand that you have your source program. It then becomes a modified source program that goes into the compiler, then assembly, and how it gets linked, and etc. You should understand that entire process. I wouldn't be surprised if it asks you a question like, what are the different steps in compiling and running a program? I don't think the whole hardware system description is that important. That hierarchy kind of really goes on in like later chapters where you learn about cache, but oh, it's hard to say. 1.2 might be important with how it describes like how things work. I would say get a lot of questions about you already have, chapter 1 has a lot of cache questions, doesn't it? I'll be surprised if you have to remember the cache systems, but I would still remember them. That might probably be useful. Yeah, chapter 1 is a really odd one because it kind of introduces the entire subject, and then each chapter afterwards goes into more information. So I would just get the main ideas out of chapter 1. So for chapter 2, you can expect tons of binary question. I would definitely imagine that you'll be asked questions like, hey, here's this hexadecimal. What's the binary of it? Hey, here's this binary. What's the hex version of it? What's the decimal value? Basically, I would expect that you'd be asked a lot of questions about translating from hex to decimal to binary in any fashion. In fact, make sure that you're able to translate to a arbitrary system as well. Because binaries, that's like base 2. Decimal is base 10. And hex is base 15? 16? 16 is my guess. He might say like something like translate this binary to base 5. Because the fact that decimal is base 10, binary is base 2, and hex is base 16, that's not. I mean, it's unique to them, but like we just went with that because it was in reality it was just convenient. There's nothing that would have stopped us from creating a base 3 system. We just don't find that as useful. That is, the base 3 system would have like the numbers 0, 1, 2. 0 representing don't add anything of 3 to the 0. 1 represents adding 1 of 3 to the 0. And 2 represent adding 2 of 3 to the 0, and so on. Yes, that is correct. Which is why in base 2 you see 0 and 1, and in base 16 you see 0 through F, or 0 through 15, denoted as character values. So I would say in general, just make sure you understand how that base 2 system comes out in play, how that base 10 system comes out in play, and how that base 16 system comes out in play. Just make sure you can arbitrarily translate to any base. I don't know if you'll ask that or not, but if you're able to do that, then you should have no issue translating between any of the 3. Let's see. I'm kind of just moving through the chapters. Word sizes. Make sure you recognize, make sure you know how the different word sizes of all the types of data variables or data types, especially depending on if you're on 32-bit or 64-bit. But luckily, if this is open book, you can see that page, which I think I recall doing. So also, I would say that as you're kind of preparing for this exam, find out, bookmark the important pages in your book. A pointer is I'm pretty sure it's only 8 bytes long on a 64-bit system. I think. Maybe expect another disconnect. I'm not sure. I think Professor Meehan has all these lab links on his Zoom account, or I'm not sure how to describe it. So whenever he wants to start one, it kind of interrupt the other one. So I'm guessing that's what probably just happened. So hopefully he understands his lab right now. Anyways, let me go back to what I was talking about. One sec. Okay. So like I was saying, I think a pointer is 4 bytes on a 32-bit system and 8 bytes on a 64-bit system. Yeah, it says it uses the full word size of the machine. Yep, that makes sense to me. Yeah. And so it's important to note that a pointer of any data variable, or I should say of data type, is always going to be the full word of that machine. That is, the size it takes to hold a character pointer is going to be exactly the same as the size needed to hold a integer pointer, since they're all pointing to places in memory. I would say that you need to be comfortable with what an array does. That is, not that it just has like arbitrary values, but the fact that if I have an integer array of say size 4, and let's call that array size A. I'm sorry, let's call that array of variable A. If I do A of 0, that is saying go to that place that it's holding memory and read off the next 4 bytes because of an integer and return that to me. And so when I say A of 1, for example, what it's going to do is it's going to jump to that place in memory, and then it says, go ahead and skip over 4 bytes of memory because of that 1, and then read me the next 4 bytes and so on. If I'd ever do, like, say, A of 3, yep, exactly. Let me see, X is going to be, yeah, I mean, I think that you got the idea of that equation. I wouldn't be surprised if he showed you like A of 3 and he was like return a similar equation or something like that. Because an array is just a character pointer. I'm sorry, an array is just a pointer somewhere in memory. So make sure you know that. Make sure you know that you can do whatever the hell you want with memory. If I have an integer, if I have a pointer to the beginning of an integer that's 4 bytes, there's nothing stopping me than converting that to a pointer and then saying I want that is actually a character array of size 4, and then reading each byte of that original integer as a character. And sorry if you can hear the gardeners outside. They always do it during this lab session, and I don't know what to do. Big Indian versus Little Indian. know how to create a pointer and dereference it. Make sure you know all the operations of Boolean algebra. So that's going to include any of the bitwise operate. Oh, yeah, it is. For dereferencing and referencing. Let me use that terminology correctly. Yeah. Know all your Boolean algebra and how the logical algebra is different. As in, there's a bitwise not, which is the tilde, and then there is a logical not, which is the exclamation point. So make sure you know the differences between the two. I would expect some Boolean algebra questions like let x equals this number, let y equals this number. What is x or y? Yes, all the logical ones will return 0, 1. So the logical ones are going to just be not and pretty much that. I mean, there's a logical and technically, maybe not technically, since it kind of just short circuits the other one. Make sure you're familiar with masking and creating masks. So if a question says create a mask where you create a mask to only get the second least significant byte, make sure you know how to do that. So make sure you know that if I do in hex 0 by FF, that is creating a mask of like the first 8 bits, and then you know how to shift that to mask out the other bytes. Basically, a lot of the stuff you would have done on Bitbasher. Yeah, I guess double. Yeah, I guess they do count. Double and double or do count as logical operators. What do you mean, like the caches? Oh, I would say it's useful. But again, I'm how to describe. Since the exam is open book, try to like strategically plan for it. If there's gonna be a bunch of like, here are the sizes of all the different registers, that's like something you don't really have to pound into your head because you can just kind of like reference that page. But you should know what the registers do and that like maybe RDX is referring to whatever register. So I would say strategically plan because it's not gonna. What you don't want to do is spend a lot of time looking up an answer to a question in the book and kind of like using up all your time. Make sure you know what shifting by 1, 2, and 3 does. So for example, if I have 8, the integer 8, and I left shifted to the left by 1, the value I'm going to get is 16. And the reason for that is because when you shift to the left or you shift by right, you're effectively dividing or multiplying by 2. So make sure you have that idea down. I'm going to keep on flipping through these chapters, see what I can find. Jump tables. Sure. What chapter is that on? Jump tables, is that chapter 4? No. Yes. End of chapter 3.6. Okay, let me check. Okay, let me look at this and give me a moment to refresh myself. Okay. What are your questions on them? Like, why do we use them? How do we use them? Or what? Why they exist? Yeah, so jump tables, you can almost think of them as like go to almost. But really they're just kind of like copying into different functions or doing different instructions. And the main idea with them is that ignoring like the generic one of just saying, "Hey, jump there and execute that code." In general, they usually are always followed up by conditional checks. Really, they're tightly linked to doing those. Let me get the proper terminology here. Um, to the where is it? To basically the conditional codes. So it has we have CF, ZF, SF, and OF. So CF being the carry flag. Thank you. Zero flag is saying if the most recent operation yield is zero, and sign flag return if negative value. So you can almost think of this as like, well, if I'm saying if some condition do this, otherwise do this, you can almost think of it as, well, if it fails, that is if it returns a zero, I'm going to go jump to that else condition. Otherwise, if it was true, I might do something else. So the main idea behind all the different type of jump tables is that they all refer to the condition codes. So the condition codes kind of just describe what the most recent kind of like Boolean algebra, not, I shouldn't say Boolean algebra, but the most recent like conditional check, like equality, that kind of stuff. And using that information, whenever you do those types of checks, are automatically stored in specific registers. And then jump condition uses those registers to kind of do other stuff. I wouldn't be able to say a really good guess on the curving scale. I don't know what Meehan does. In the past, let me check if I still have my Canvas course to see if I got a curve. And so when you look at the jump table, you can see that the jump condition is a bunch of these arbitrary statements about using all those previous condition codes. And certain Boolean operations using those condition codes will yield certain results. So like we saw here with this SF, if that's one, that means we're negative, and if it's not one, that means we're non-negative. And you can do more stuff than that to get all your kind of ideas. Sorry, to get all your typical as in, let me phrase this. If I'm doing a check where I say if X is greater than Y, do something, then essentially it's running that jump condition of greater, and then it'll use that instruction to jump to that code. Yeah, I can understand it's probably a difficult quarter with computer systems with Meehan and the quarantine. It's not a great combination. It's also one of the more difficult entry courses. Yeah, I took this course. When was it? I think last spring. With Meehan. Yeah, I remember needing to read the book a lot. No, winter 2019. Um, I'm not sure how much of this information would be useful. I can tell you that on the first exam, when I took it, the average was 29 over 54. So that's roughly like 60% is the average score. On the final exam, average was 75 out of 126. Oh God. Divided by 5 times by 4. 75 divided by 5. That's 15 times by 4. 30, 60%. It's extremely book heavy. The course the grade I'm describing right now, yeah, that was with Professor Meehan. Um, I don't know. I guess I can't really comment on too much being his TA, but it's hard to say. I think the department would have more information on if students are routinely doing poor. Because I mean, I think there are classes where maybe the professor expects everyone, like maybe the professor expects the high to be 70%, but then he curves where 70% is actually an A. Um, I think those type of situations might be okay in my opinion because it's like, yeah, you're getting a lower grade, but ignore that because we're going to curve it later on. But it's hard to say with Professor Meehan. I don't know what he does. Yeah, like I mentioned, it's a very book heavy class and it's very easy to fall behind. I've only taken it with him, so I don't know how it might be with the other professor that teaches it. Oh yeah, I was hopping around. So yeah, we talked about jump tables. Let me go ahead and hop back to floats. Make sure you know how overflows work. Make sure you know how to do 2's complement. I think there's a thing called 1's complement too. Oh yeah, there is a whole section on dividing powers of 2. Yeah, integer arithmetic might be a good section to review. A lot of dense information in there. All right, floating points. Those are going to be important. So make sure you understand IEEE's floating point standard. It might ask questions like, which are the denormalized cases? What are the normalized cases, etc. Make sure you know how to get the smallest normalized number, the largest normalized number, the smallest denormalized number, that kind of information. You should know why the normalized and denormalized case exists. Specifically, we have the denormalized case because we're saying like, okay, well, we could have continued on that pattern where say we knew every 0.1 of a number, but since we really care about getting those very small, precise values, we leave more room to for them. Understand the exponential, the exponent bias, why it exists, why we don't just say, hey, let exponent be a signed value and not. I shouldn't say let it be a signed value, but understand why it's treated as if it was an unsigned value rather than a signed value. Specifically, we do that because for offsetting 2's complement, why we use exponential bias? Maybe if I'm understanding where you're getting at, the idea is that because otherwise there's going to be there's a negative 0 and a positive 0 is kind of the main idea. And so we really don't want to just show 0 and no, let me think about that again. I think I gave that correct answer. It's specifically, I'm blanking out on the answer, but it specifically has to do with the fact that we don't want to have a negative and a positive value meaning the same thing. I think it is the 2's complement. And so by allowing it to be a exponential, allowing it to be unsigned, let me rephrase, by allowing it to be treated as a unsigned value, we get one more bit. And using that one more bit, we can have one more value. So we have that offset now, where we range from, I want to say, from 127 down to negative 128. And the idea is that, well, why did we not do 128 to negative 127? And the idea is that we want to represent more smaller values than we do bigger values. So understand that concept, how we compute the exponential exponent bias, why it exists, why don't we just treat it as like a signed value, that kind of info. I bet you probably be able to fully expect questions on like, hey, what's the given this float, tell me, write out in binary what its mantissa looks like, what its value is, what its fractional component is, what's the exponent is, that kind of thing. And be very careful that you pay attention to the symbols. Depending on what exponent you're talking about, we can either be talking about the exponent without subtracting our bias, the exponent once we subtract our bias, or when we do 2 to the e, which is just taking it to the exponent. Excuse me. So make sure you're comfortable with how floats are represented and being able to be comfortable with like writing out a float in binary. And you can probably expect that it won't get you to write a overly complicated float, but you should at least be able to do like the smaller values. I wouldn't be surprised if you're asked questions like, write out the binary for the largest float possible, the smallest float possible, write out the binary for positive affinity, negative affinity, etc. I wouldn't be surprised if you were asked those type of questions. Let me continue forward. Rounding, make sure you know rounding and why we do it in a certain way. Like the fact that 1.5 goes to the nearest, I believe, even value. Yeah, round to even. But also just what the different roundings are. Round to even, round towards 0, round down, round up, and why we might choose between them. It's all by the EEE standards, and let's find out what float does. It should be in here. I think round to even is what happens, but let me verify. I'm pretty sure round to, oh, I'm not sure. Look up the IEEE standard on it. That's going to be what actually happens in reality. Yeah, I don't know. I would look it up. It's either going to be round to even or round to nearest, where 0.5 is straight up. I'm pretty sure it's round to even because round to even is the most statistically average. Like if you always round down, then your numbers are going to be a little lower. If you always round up, your numbers are going to be a little higher. And round to even makes it so that you always kind of round roughly equivalent up and down. And let's go to chapter 3. And again, I would make sure you guys look through the books, and if you see a page that is useful, make sure you bookmark it. You don't want to spend time on the exam trying to find out the page of registers when you can just jump to it. You got to know assembly, unfortunately. So you should probably be able to be expected to look at some assembly and kind of decipher what it does. I would expect them to not be overly long, but still expect to like kind of have to transcribe it. It might be like, look at this assembly. Which of the following options are going to be most similar to what that once compiled will result in the assembly? Is it useful outside this class? It depends. So there's going to be a mini rant. So I hear a lot of conversations. I see a lot of conversations on Discord um, suggesting that um, it was like I think it was conversations on like whether or not this class is useful. And I'm going to be taking the stance from I do research in deep learning, so I'll be taking the stance from that. I think it's useful because you don't do in once you let me think. I program in a lot of high level languages, so mainly Python. So I don't normally do all of this C stuff, but it's very useful because if I know that if I ever need to multiply by 2 quickly, I can do bit shifts. And there has been problems in the past where I'm like, okay, how can I do this more efficiently? If that's really the answer, if you need to do something efficiently, then learning all these bitwise and whatnot operations very useful. Learning assembly probably not too important unless you're actually working with compile stuff, because the idea of learning assembly is how you do things very efficiently. There can be little shortcuts where it's really hard to tell the compiler to do a very specific instruction when you're giving the source code. Like, there exists a certain optimization you can do in assembly, but the compiler isn't understanding how to do it. You could then go into the assembly and alter it yourself. But again, that is going to be very specific, like low level optimization. And ideally, the compiler kind of picks up on that and learns to perform those optimizations. So it's hard to say. I think it's useful information, but depending on what you focus on in CS, it might not be that important. Does that answer your question? It's mainly very useful for low level stuff. So this is my perspective from like a high level programmer. Let's see. Registers are going to be important to know. And there's operations. Yeah, they're going to have the base displacements that were a lot of the array stuff I was describing earlier coming to hand. What type of rules are you kind of referring to? Yeah, it's just a little odd. You also have to keep in mind that as you kind of step down from source code to assembly to machine code, every time we do that, we kind of lose information. And so it's totally possible that 2 source codes produce the same assembly code. Because this is, I believe Meehan would have talked about this, is that when you're getting the assembly of your code, like just when you're testing out on your homework assignments or whatnot, you should not compile it normally. There is a flag, which I don't recall off the top of my head, that you can use with GCC that says, hey, don't apply any optimizations to my code. Because that's what the compilers will do. They'll recognize that if you times by 2, it should left shift by 1, because they recognize that that is a faster operation to perform than actually timesing by 2. But if you tell it, hey, don't do any compiler optimizations, it will probably return a different set of assembly instructions that just says times by the constant number 2. In the lab, if I open up GD bomb and type breakpoint explode bomb, I believe so, Ben, but don't take that as me saying yes. Um, the only reason I don't want to say yes confidently because if it does fail, you'll miss the point. What I would suggest that if you really want to get comfortable with using GDB and like make sure like do these quick sanity checks is that you write a new program and you know just having a main method and then maybe have like three additional functions f1 f2 and f3 and then just call those within your main method, compile that program, and then test GDB on that. Try to set breakpoints at like function f3 and then see if it does do what you expect to occur. So I would say test it out and make sure you're confident about it on a separate program that doesn't matter before doing it on the bomb lab. Or if you just want to go wild and set a break, just go for it. You can do that as well. I think it just really forces you to not like just try things and be like, here's an answer, let me run it. Oh, it doesn't work. Let me try it again, and so on. I think it's really meant to encourage you to kind of like sit down and like specifically think, am I doing the right thing? So I don't know. I think it's an interesting lab when I did it. I would say like the saving grace for the lab is the fact that you can set a GDB breakpoint and like have it not triggered. If it was like a sort of situation where like if you even put the wrong answer once, then you lose a point, then I would probably be a little more upset about it. .s. I don't know what's in the Canvas files. Professor Mehans has a lot of files in there. But if I look at somewhere, let me look at the book real quick. It'll show all the different steps of how programs compile. .s is going to be assembly. That's what it is. Yeah. So it's some type of assembly code. I don't know what it's for. If you find a fixed matrix.c, it's probably the assembly for that code. Let's see. Generally, you just should know a lot of assembly stuff about the procedures, about the conditional codes, about jump, and how that kind of works. Like, I would expect that you might receive a question saying like, okay, look at this operation, and it does something, and it will say, what's the carry flag? What's the zero flag? What's the sign flag? What's the overflow flag? That kind of stuff. And then using those, it might then ask the question, what would jump not equal to evaluate to, or that kind of stuff, or like was x greater than y, that kind of information. Like given that these were the flags that occurred, was x greater than y, that kind of information I would expect. And that kind of was my quick overview of the first three chapters. I would still give them each a read and then look at each of the practice problems and see if check to make sure you have a good idea of how you would go about it. Stacks are going to be important. Stacks are wild. So make sure you recognize how to use stacks. Yeah. Overall, the flags, like the carry flags. Yeah, so that's going to be at the beginning of chapter 3.6. And so I'll go by one. So it says carry flag, the most recent operation generated a carry out of the most significant bit. Compare and test. Yeah, so it's sort of a little interesting, and let me think about it for a moment. Because like when you do a greater than check, it doesn't actually do like a greater than operation. And sort of in a certain light it does, in a certain light it doesn't. Um, we can see that when it does compare, it actually does like S1 minus S2. And so if we ask the question of like is 4 greater than 3, we can see that doing 4 minus 3 it still results in a positive number. Thus, we know that 4 was greater than 3. But if we do a check like 3 greater than 4, if we do 3 minus 4, that results in -1. And because of that sign flip, we saw that the carry flag occurred. Or sorry, no, the carry flag did occur because the most significant bit was changed. And the idea is that to do all these weird operations that we want to do, greater than equals, less than equals to, is equivalent, not equivalent, all those weird conditions, they all kind of use these 4 flags in a certain way. And so, for example, we can see on page 187, which might be different depending on the edition of the book you have, greater is actually going to be using the sign flag, the overflow flag, and the ZF flag, zero flag. Which kind of makes sense because it would be like if you have a negative integer and you subtract, you ask if it's smaller than another number, and then we expect to see kind of like that overflow to occur once we do the condition. And so, yeah, so the comparison is always going to be S2, S1, and then it will do S1 minus S2. Zero flag, I think that's kind of self-explanatory. The most recent operation yields a 0. Sign flag, same thing, it will yield a negative value, and overflow is denoting that an overflow occurred. And so we do the compare to assign these flags essentially, and depending on what they were assigned to, we have a certain condition satisfied. So you can almost think of this as a truth table. Like if carry flag and zero flag, but not sign flag, then something occurs. And all of those are going to be described on 187. And test. So that compare would do the subtraction. And let me refresh myself on test real quick. Yeah, essentially. So to do if we're saying that some variable is less than or equal to 0, we're asking for a very certain condition to occur, which is going to be based, if we know if something's less than or equal to 0, if we have certain flags that were set off. In this case, doing less than or equal to would be the equivalent of saying the sign flag XORed with the overflow flag or the 0 flag. Yeah, give me one moment. I'm trying to refresh myself on that. And I don't remember what it does. I want to say it's used with equivalency checks, but that doesn't also make sense to me because you can just subtract them, and if you get the 0 flag, then they're equal. Two. One second. This is 1 and 1. Let's see. I'm going to say my answer would be that you won't be able to get all the conditions you need using just comparison alone. So I think one issue that you might find with comparison is how do we know if two things are true? Not even from like a let me think about that further. That's my intuition, and I'm trying to think of a concrete example to demonstrate. Because we can kind of think of this just kind of logically. So comparison is always going to do kind of a subtraction check. And so that's going to be useful for a lot of our greater thans that's needed. And I want to say that it's going to start to fall flat once we need to do not greater than or equal operations, but when we need to do the other ones, which are going to be, excuse me, namely probably negative, non-negative. That would make sense. Let me think about that for a moment. I might have to work on an example to figure out one that might be useful. I know for sure that you won't be able to cover everything with comparison. It exists to kind of cover the gaps that comparison doesn't handle. But a concrete example would be nice. Because they're all going to set the same flags regardless. They're always all going to set the sign flow, zero flag, and overflow flag. Though, that being said, I don't think test can even set the overflow flag. Let me think. So if it's 1, 0, it performs an AND operation at the very least. And it probably would be useful if we say that x greater than 0 and y greater than 0. So x greater than 0 and y greater than 0, those are both going to be comparison checks since they're going to be x minus 0, and we notice that a sign doesn't flip, therefore those are equivalent to true. But when we have the AND operation, we can just AND them and notice that since the flag doesn't change, that means they were both true. And in the 0 and 1 case, we can find that out of the most recent operation, the flag will change. Is that about right? Yeah, sorry, I don't think I can give you a concrete example right now. Let me search around a little bit further. But the main answer would be that it covers gaps that comparison does not cover. And specifically, I think it covers the AND gap, but I'm having a hard time thinking of a solid example for that. Yes, if that's what the order of the book says. S2, you do S1, S2, yes. So it depends on the result of that. So suppose that I was comparing 5 and 4. As in S1 is 5, S2 is 4. So we do 4 minus 5, and that results in a negative value. So there's a couple of things that occurred. The sign flag is now set because the most recent operation, that is 4 minus 5, yielded a negative value. The 0 flag is not set because it's not 0. The carry flag did it generate operation? No, we didn't have like a well, it could have been carried out. The carry flag could have been set. In this situation, it was not. And then the overflow flag was not set either. So in this case, we would only have the sign flag set. And if we look at the sign flag for greater than, it's essentially what it describes. So ignoring the whole fact with the overflow, it checks to see if the sign was flipped and if it was not result in 0. Let's think about it. So 5 minus 4, or I should say 4 minus 5, is negative 1. So the sign flag was definitely flipped for sure. I want to say that the carry flag was not flipped. Because you're essentially adding a negative value. So that would not have flipped the sign. So I would say the carry flag was not set. And the 0 flag was definitely not set. And we didn't cause an overflow. So that wasn't set either. So yeah, I would say that only SF was set. So yeah, let me write this out. SF1, CF0. And we can kind of like go down the line. So if I'm looking at it, the equal condition was not satisfied because ZF is not set. So the not equal condition was satisfied. So if I was doing 5 not equals 4, then they would not have been equal. It's kind of interesting because it's kind of almost agnostic to the idea of the operation. Like regardless if we were doing 5 greater than 4 or 4 greater than 5, we would still do a comparison between the two of them. We only care about the effect afterwards. So then you would have the new values as the flags. You can use CMove or J with the suffix you desire to test the flags. Yeah, so depending on like a lot of these assembly things are going to have specific suffix that refers to one of those unique conditions. So for example, set NLE it's a set command, but not less than, or in this case greater, not less equal. That is greater. So those flags are kind of just set in the background. Like once we do a comparison or a test check, those flags are set. And then we can kind of do what other operations we need. And a lot of times these assembly statements such as set NLE is still going to do a set thing conditioned on the fact that these certain flags are set. And if you look at 187, those are going to be all the conditions needed. So kind of continue on with the example of comparison 5 and 4, we would see that they're not equal because the 0 flag was not set. We would see that the negative flag was set, so just suggesting that the result was negative, which is true, and that means thus the non-negative flag is false. Greater than is going to be kind of interesting. So the sign flag was set and XOR with overflow flag, so that's going to result in a 1. Negated is going to be a 0, and negation of the 0 flag, which means that it was not greater than. So in this situation, I'm saying 4 was not greater than 5. But if I go to the less than, we can see that the sign flipped or overflow occurred. And in this case, the overflow is 0, but the sign did flip, which is 1, which indicates that we are in the less than situation. In this case, in this example, this was, we're checking to see if 4 is greater than 5. And as a result, we did 4 minus 5 as our comparison. So when you say JG, what flag is it checking? So that's going to be a jump method followed by G, which is going to be less or equal. Or no, sorry, that's NG. I believe that's going to be jump greater. There should be a table that has this. Wait, JG is not a thing. I believe it's going to be JNLE. Or if JG is a thing, it's probably shorthand notation for JNLE. Oh, wait, no, J. Is this an M? Perfect. Okay. These people at Intel or AMD can kind of come up with any symbol they want. Yeah, let me look at that thing you just posted. Yeah, that's going to be the nasty greater than. So we can see in this situation, if you work out the math, that will evaluate to false, namely because the sign flip did occur and the overflow did not. So that's going to result in a 0, sorry, a 1. And then negated is going to be 0. And then it's ANDed with, it doesn't even matter what it's ANDed with because it's 0, resulting in 0, which indicates that it was not greater than. But if you look at the less than situation, sign flip XOR overflow, we find that overflow was 0, sign flip was 1, therefore it returns 1, which means that we are in the less condition case. And we'll also find that less than or equal to is, you can see that it's pretty much the same statement as before, but it's also going to be ORed with the 0 flag just to account for that equal check. They're set for an operation, yeah. So when you do the comparison or test, it will immediately set those flags. What do you mean 4 to 5? Oh, sorry, 4 minus 5. Yeah. So it's really, we're doing the comparison check. And to do the comparison check, we do 4 minus 5. And as a result, certain flags are set. And we can kind of do it the other way around too. So let's do the comparison of if 5 is greater than 4. To do so, we do 5 minus 4, and we get the value of 1. No, it's not every variable. These are just kind of like flags that are set. Like I think they're specifically, I think they're on their own registers, but don't quote me on that. Look at the book and verify that. But they're mostly temporary in nature. So if we do 5 minus 4, we find that A is essentially equivalent to doing 5 plus negative 4, which means that no carry flag occurred. No 0 flag occurred because we had 1. A sign flip did not occur because we still have a positive value. And we didn't have an overflow, so everything's 0. And a result, if we look at the greater than situation, we see sign flip XOR overflow. Well, neither of them are 1, so that results in 0. The negation is 1, and the negation of 0 flag, which is 0, so the negation is 1. We have 1 and 1, and so that indicates that a greater than condition has occurred. I know that was me kind of just saying it a little quickly, but the idea is that if you kind of like do these kind of equality checks, write them out on paper, and then kind of like follow these commands. I should say follow these that table on 187. You can kind of indicate what occurs. So an example would be, well, like how you might be quizzed on this. I would imagine that you might be like, here's x greater than y. Let me type it out so you can see what I'm. You might see a question like that where it says, "Oh, look, x is greater than 5. Here are the things that occurred. SF was set to 1. Carry flag was, I don't know, 0." I'm just gonna make some of these up and see if we can find anything interesting. I don't know. And suppose those are the flags that are set, and the question is, what happened? And so that would basically be doing the comparison of x minus y. And we know if sign flipped occurred. So that would either mean that x was positive and y was some greater positive number, but not necessarily, because it also could have been that x was a negative value and y was a greater negative value. I think that already indicates that it's greater than, actually. Am I right in thinking that? No, I'm wrong in thinking that. Let me think for a moment. It'll be x minus y, which will resulted in those flags, which mean a sign flip occurred. I think that sign flip is already indication of something already. Right? Because x could have been a positive value and y could have been a greater positive value. Oh, that's naming the situation, I guess. So if x was 1, x could be 1 and y could be 2. And so when we do x minus y, that's going to result in a negative value. But x could have also been negative and y could have been more negative. That is, say, -1 and -2. And so -1 minus -2 would result in 1. In the first example, when I do x is 1, y is 2, y is clearly bigger. In the second example, when I do -1 and -2, x is clearly bigger. But they both caused that sign flip to occur. So we don't have enough information quite yet to figure out what occurred. And so we keep on moving down. Or maybe I'm lying to you guys. It's been a while since I've done some of this. Let me just check myself. But I hope you guys are getting the generic idea of how you would go about doing this, even though I'm doing a poor job at it right now. The carry flag doesn't seem to matter. So am I thinking about that correctly? There, I'll give him a moment. Yeah, minus -3, that would be 1. The overflow flag did not occur. Carry flag. Sign flip to 1 or 0. I think this is suggesting that we're in the less than case. which means we did not satisfy the greater than condition. I'm having a hard time realizing why that might be true. One second. Anyone else has suspicions on what I'm doing wrong here? And I know that sounds like a trick question, but I actually don't know what I'm doing wrong. Yeah, it's very odd. I must be doing something wrong. Yeah, that's going to result in 0. That means we're not. The trait thing I'm getting confused about right now is that this can either occur if X and Y are both positive, but Y was more positive, or if X and Y were negative, but Y was more negative. Those are the two conditions that a sign flip could have occurred. And I have a little suspicion that it probably, when it did the comparison, it probably did it in a smart way. Let me think. So -1 is clearly larger than -3, and that caused a sign flip to occur. But 1 is clearly smaller than 3, and that caused a sign flip to occur as well. Maybe. Yeah. I think that's exactly it. Yeah. So we have two conditions. Either, well, if we do then y minus x, we need a sign flip to occur. And the only way a sign flip can occur is x if x was greater than y. Am I understanding that correctly? So x must be greater than y, but that doesn't seem to work out in our situation. I think I may have. I don't know if I'm able to just come up with these questions or this little quizzes on the fly. I think there's special care that has to be handled in making these tests. Let me think about this more. If we do y, if we're doing a check of if x is greater than y, we could do y minus x. And we're saying that results in a sign flip. So that means x, well, it could be that y was a negative, so -3, and x was just a bigger negative value. Or it could be that y was positive and that x was just more positive. In this situation, in the first situation, y would have been yeah, there's a certain order to it. So I guess take the fact that I'm a little hazy on it as a warning to review it yourself. Let's see, yeah, -3 minus -4, that results in a positive value, but that's suggesting that x is not greater than. But in this situation, if we do 3 minus 4, that results in a negative value, which will still actually suggest that x is, no, that would suggest x is greater than. In this situation, it would suggest that x is not greater than. That's weird. I wonder what I'm messing up on. Um, I'm not sure. I'm going to spend a little bit of time reviewing that information today. And if you join the little study session tomorrow, I should be able to give a better answer then. Sorry for not having that answer now, but I'm a bit confused on it myself. I'm tempted to say that it also does additional checks, but I'm not sure. Oh, I think I know what I'm doing wrong. Yeah, okay, I see the mistake I was making. I think I'm going to set it as 12. Right after this lab, I'm going to make an announcement. Sorry, I misspoke earlier. The sign flip, it says the most operation yields a negative value, not that the sign was flipped. I keep referring to it as flip since I saw the F, but it actually refers to the sign flag. So if we're doing the whole x greater than y operation, we don't consider the case of -3 minus -4. The reason is because the sign flipped, but it did not remain negative. So in that example I posted, the fact that that sign flipped means that when we did, I want to say y minus x, there's going to be an order to it. I'm going to assume that it's y minus x. When we do y minus x, that resulted in a negative flip. That means that x was strictly greater than y. Because if y was a positive number, x would have to be a greater positive number. If y was a negative value, x would have had to been in speaking in absolute terms, a less negative value because it had to remain negative. So if y was to subtract the negative value, that negative value itself could not be as small as y in the absolute sense. I think that was the main issue of point of confusion for me. Did that make sense? Cool. And the way it's going to be doing it is by an order. I could probably record the session. I just have to think of the logistics of like where I would upload that and whatnot. Or I might do multiple sessions, depending. I might just be on my desktop doing my normal assignments and just have the Zoom open in case anyone has questions during that period. I have to think about it. But yeah, I'll see about seeing if I can't record it. Any other questions? Why I'm still here? Mhm. What I might do is set a study session from like 11 to 1. I don't know. We'll figure it out. I'll look at the unofficial poll. No. Yeah, I probably wouldn't set it at 11 since only 2 people voted for that. The issue is there's a lot of people in the morning and then in the evening. Maybe I'll just split it up into like 2 sessions. I don't know. I'll think about it after I have lunch in a moment. You guys didn't go beyond chapter 3 yet, right? Oh, converting C to assembly. I would say there's probably I would imagine there's questions like that. I would imagine you again take this as like a me guessing. I haven't looked at the exam, nor did I help write it, so don't take this as absolute. I wouldn't be surprised if there was questions asking you to convert. I would be probably suspecting there'd be problems like x is assigned to 1, x then is timed by y, then we shift x to the left by 3. Which of these following options would be the assembly code for the C? Those type of questions. Or look at this assembly code. Which of the following options below best accurately represent the assembly code? And you have to like pick up on some stuff. I wouldn't be surprised if some of them would be like you times by 8, but in the assembly code it shows a left shift by 3. Because you have to kind of like think to yourself, well, okay, that's not directly doing times by 8, but that is still achieving the same result. But then there's some of them that are going to obviously be wrong. They're like, left shift by 63. I'm like, well, I don't do any left shifting and it doesn't seem to accomplish the same task. So that can't be the answer. That kind of stuff. So I say you should probably expect to see assembly and be able to convert between the two. So make sure you have the pages handy on like the different registers, what they are, that kind of stuff. Yeah, and when I say run through, I don't mean like actually do them. Just think to yourself, can I solve this homework? Because I think it's kind of unreasonable to do every single practice problem because who has time for that? But at the very least, look at the problem and think to yourself, can I answer this question? And do I feel confident in being able to answer this question? If the answer is yes, then you probably don't have to do that problem. But if the answer is no, then consider doing the problem. Or at least figure out how you would go about doing the problem. Because really going through the practice problems, that would be a very easy sign of showing what you do know and what you don't know. If you're struggling with a lot of the float questions, you can, it's very easy to identify that, oh, I'm actually having an issue with the float concepts. Let me review those. So that's just kind of my study tip. But I guess in reality, the best study method would be whatever works best for you. I know that sounds very vague, but it depends. I'm the type of student who likes to constantly go through practice problems again and again and again, making sure I can kind of like nail them all down. Um, so it really depends on what works best for you. So that was just my suggestion. I'm hoping tomorrow, and I'll mention this in the Canvas post, that it would mainly be questions brought from you guys. So it'll be heavy emphasis on making sure you guys have questions prepared for me, because I could mindlessly just kind of go through the chapters again and kind of like talk about each point, but I feel like it would be a much more productive session if once it's running tomorrow, someone says, can you talk about exponential bias? And I can kind of go in depth about it, and then people can ask questions or clarify thoughts. Because oftentimes people think of questions that others haven't thought of, and vice versa. So that's going to be the main emphasis, is that students are bringing their own questions in. So it's going to be as productive as the students are. Is that the way you say it? It's going to be as productive as the questions are productive. However you want to spin that. If that makes sense. I'll be honest, I'm running a little low on food right now, so I'm a little tired. But once I make the Canvas announcement, I'll try to make it all clear. But for now, I'm gonna hop off and get some food before my next meeting. So I'll see you guys.